Now we have defined these load patterns, but now we need to correct these loads also. That is, we need to check ELX, left click on modify later load, and here we need to uncheck all these options. Response reduction factor can be R equal to 3, and zonal let it be 0.16, site type 2 can be SS2, importance factor I equal to 1, and time period can be program calculated also, or you can also manually calculate a time period here. Along X direction, the length of the portal is approximately 40 meters. So as per the Indian standards, the time period is approximately 0.075 into h to the power 3 by 4. The height of the shed is approximately 5 meter plus 2 meter, that is 7 meter. So 7 to the power 0.75 into 0.075. So time period is approximately 0.322 seconds. So left click on OK. Similarly, we enter time period as 0.322, y direction 0.16, r equal to 3, and then left click on OK option. Wind load we need to assign it as UDLs. So left click on OK. After that, we need to define a response spectrum function also if we want to do the response spectrum analysis. In the structure like this, where there are various portal frames and there are openings etc. for the wind loading to act, 99.9% wind load go on the design. So now we have defined the load patterns. After that, we need to define the load cases. All the load patterns are automatically imported to the load cases. But if we want to do the response spectrum analysis, so first of all we need to define a response spectrum function. So here we can select IS 1893 2016, left click on add new function, name the function as IS 1893, seismic zone 3, importance factor 1, R equal to 3, and damping ratio for steel structures can be taken as 5%. So left click on OK option, and then again left click on OK. Save the model. After that, we need to define the response spectrum load case. So we name it as RSX, load case type as response spectrum, and here we need to add acceleration U1, function as IS 1893, and scale factor we need to change the units here. Left click on show units form. Here we need to change the acceleration to meter per second scale. Left click on OK, save, and first of all we also need to define the mass source here. Dead. Live loading on the roof is not considered, so we can skip live loading in this case and we can add collateral loading. Here now warning will appear because we have taken dead load also as well as element self mass also. So left click OK and then again on OK. So after that we need to go to load cases. We need to add a response spectrum load case here. So we name it as RSX, load case type as response spectrum analysis, and we need to acceleration U1, function IS 1893, scale factor 9.81, and similarly for RSZ. The load name has to be U2. Left click on OK, and then again left click on OK to save this model.